Let's cover it so we have it. All right. Now I'm going to I'm going to draw on the screen, so the sample radius thing goes away as soon as I press the keys that I need. So let's just return this to 0.75. So the standard brush by default is set at 0.75, and what that's saying is that out of this entire width, it's going to calculate from the center, mind you, it's only going to calculate 75% of that. So this is 50, this is 75. So if we were to draw that, 0.75 in my horrible circle represents that red line. So sample radius of 0.75 means that ZBrush is going to use all of the polygons inside this area to create an average direction. Or if you were to look at that from a side view, let's just move that over, the old perspective trick. So the brush would normally be covering this much of the form. In this case, the brush is only going to be using everything within this red line to determine what the direction of that brush should be. That's the long and the short of it. Now let me go in green lines, and let's say we set our sample radius to not 0.5, but let's set it to 0.25, so that all we're getting is this little tiny area here. You pull that all the way across. That means that out of a very large brush, it's only going to use the vertices within this small area to calculate what the direction of that brush is going to be. Why is that important? In a sphere, it's not terribly important. But when you have a lot of surface curvature, it's important. So I'm going to give you a metaphor that I want you to hold on to. The wider this is, the more like driving a semi or a tractor trailer. The more you just barrel through the surface. The smaller this is, the more responsive it is. The more sensitive it is to changes, like a Porsche. So ZBrush likes to see itself in the metaphor of sports cars. If your brush sample is all the way to 2 or 1, you're driving a tractor trailer. If it's set at 0.2, you're driving a Porsche. It's very responsive. And I'll give you one drawing to help understand that a little bit more, and then we'll put it into action. Okay, so your draw size, it's going to be hard. Let's say you're at 0.25. You're pretty, there's no real difference right here. If you're sampling 0.25, if you're sampling 0.5, it's not a big difference for what that sample is going to be here. When you get into this area and you're sampling, well, just that point, just this point, just this in this area of tight spaces, this is when the amount of sample makes a difference. For example, imagine that you're sampling 0.25, and that's all of this. Your surface normal faces off to the right. Okay, imagine that you're sampling 0.01, and that's right there. Then your surface normal is facing this way. Different directions, right? But let's imagine that you've got your sample set to 2, and it covers everything. It's more like a tractor trailer, barrels through. So you'll see brushes with different levels set there. Let's take a look at our guy. I think this might be the best way to demo it, especially since you've got him. This is important because of some backlash that you can get in your model sometimes, in your brush stroke. So let's look at trim dynamic. 0.45. Okay, and this is the clay brush, so it's designed to, be pretty responsive with topology. Let's take that sample radius all the way up to 2. And I'm just brushing along the surface. Doesn't it look like I just drove a tractor trailer over it? A couple of broad strokes. Go back to that 0.45. It's a little bit more sensitive. Okay, so let's come and take this all the way down. This is so hair trigger sensitive that it starts to introduce artifacting. And basically what's happening is you have the brush responding to the surface, but then it's so hair trigger sensitive it'll flip and just do weird things. It seems weird, but it's responding mathematically correct. It'll flip back and forth, and that's because we have that sample radius at 0.02. So it's taking a tiny percentage, 2% of that radius. Makes it really, really sensitive. Let's take a look. What does Damien's standard brush have? 0.75. Some brushes respond to this, others don't. I'm dropping it all the way down. Dropping it all the way up. Let's take that all the way. All right. Now you may or may not have noticed, and depending on the screen resolution in the recording, the feeling of using 2 was that, boom, it drove through everything. The feeling of using 0.75 was, well, it drove through, and here it flipped a little, and then it got normal. Okay. The feeling of 0.02 was flipped out a little, flipped out a little, flipped out a little, and then normalized. And that's all it is. So if your brush is flipping a lot, what are you going to do? Are you going to increase your sample, or are you going to decrease? You tell me. If you want to stabilize your brush, are you going to increase samples, or are you going to decrease? 100% increase. Even though there are all these nice fancy settings in here, stabilize orientation, stabilize direction, the first step on this is your sample radius. Okay, because no matter what, sample radius is determining how much of your brush, how much of the area of your brush is being calculated. After that, stabilize orientation will take that portion and just stabilize it. Do what it can to affect it. Most important thing is sample radius, though. Let me see. What does trim adaptive have? Look at that. 0.1 for trim adaptive. Let's calculate that. Let's work on that. And think about, why would sample radius be 0.1 for adaptive? What does trim adaptive do? Crazy. What trim adaptive does is it picks a point and then it flattens all the polygons. So trim adaptive is 0.1 because it's assuming that the user is going to move the cursor to a point in space. Like let's say I'm going to move right underneath this eyeball and I want to make everything conform to that normal. Now if my sample radius was all the way up at 1, then it has to calculate that normal, that normal, that normal, this normal, that normal, and then now things start to flatten out differently. So it is possible that instead of getting that down plane, the down plane will change. Again, a very small thing, but knowing that is really a key to you kind of understanding these brushes, because this is technically a very different behavior. I mean, I'm using trim adaptive because I want to take that polygon plane and flatten it. And I can also press Alt and start to create kind of specific mechanical details. If I had my samples up too high, which I do, then things start to behave, you know, just a little differently. But now this is much more of a mech. I did a demo a long time ago, and I think a lot of people have done it since as well. You want to turn this guy into a mech dude? This is a great brush. Back in the day, that's what you would use. Okay. Now, stabilize orientation, stabilize direction, like I said, there are going to be minor elements to that sample radius. So let's talk about those in their own components a little later. And let's get into modifiers. There's a lot of stuff in modifiers. Of course, there's brush modifier, and it is likely that I'm going to lose my voice. So I tell you what, guys, let me ask you, how about we go till 3, and then we'll call it a day, and then when my voice recovers, I'll make sure that you have the rest of my lecture pre-recorded. I'm fine. This doesn't hurt. It's just starting to sound a little, sounds like it hurts. Alrighty, guys. Peter, I love your idea. Hot whiskey and honey. Alrighty. So we got about another 20 minutes then. We'll see if the language holds. So with that done in mind, I'm going to simplify this a little bit. And that'll affect my depth of each feature. But like I said, I will record much more in depth for every part that needs it. I love this stuff. I mean, this is why I teach ZBrushes. I love figuring this stuff out. This is the system. You figure this system out, you have much more control. Okay, so modifiers. There's a lot in modifiers. Let me show you guys that all in a separate thing, because there's things like this tilt. What does tilt do? We're going to talk about it. I'm going to show you it hopefully today, but I don't want to get in and explain it in and of itself. It's pretty awesome though. Let me make sure that I do that. Snake. We look with snake scales. Tilt. Okay.